So, welcome to 24 Hours of PaaS, Evolution of Data Platform. We're excited you could join us today for a Grand Fritchey sessions. Perfect fit for Azure SQL database migration. This 24-hour PaaS event consists of 24 consecutive live webcasts delivered by expert speakers from the PaaS community. The session will be recorded and posted online after the event. To access any on-demand sessions, please visit www.24hoursofpaas.com for all session links. My name is Edvaldo Castro, and I am a member of Brazilian SQL community. I have a few introductory slides before I hand over to the Grant. If you require technical assistance, please type your question to the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any question throughout the session. Feel free to enter your question at any time, and once we get to the Q&A portion of the session, I'll read your question aloud to the speaker. You're able to zoom in on the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation after the end of the session. Your feedback is important to us, so please take a moment to complete it. It will appear in your web browser. I'd like to thank you, to take a moment to thank our presenting sponsor, Microsoft, Amazon Web Services, HardWorks, and Redgate. Redgate makes ingeniously simple tools for a Microsoft technology professional working with SQL Server, .NET, Visual Studio, Azure, TFS, trusted by 91% of Fortune 100. In addition, I would like to thank you supporting sponsors for this event: Hewlett-Packard Enterprise, SQL Century, and SanDisk. The staging of 24 Hours of PaaS would not be possible without their generous support, and they are the reason this event is available for free of charge. Make sure you explore everything PaaS has offered for the data professionals. You can join local user groups around the world, special interest groups, find free online resources throughout our Learning Center, and read up the latest community news in Connector newsletter. This session is presented by Grant Fritchey, and now I'm giving you the word. You can go ahead and have a great presentation, Grant.
Thanks, Edvaldo. Appreciate the time. Let's get going, people. All right, I want to talk to you guys about Azure SQL Database, and I want to talk to you about making migrations, making the move. Let's talk about, just getting into Azure and making it happen. So, the cloud. Let's face it, Azure is in the cloud. Azure is, as someone once put it, the cloud is just other people's servers. And yeah, it is. That's just the way it works. It's just something to think about. You are moving away from how you've been working stuff. You're moving into a new space. It's going to be different. And so you need to take that into account. It's not, everything's not going to be, rainbows. It just isn't. There's stuff that we need to talk about. Now, most people, what they want is they want to soar. They want to get out. They want to take off. They want to fly. They're going to get into the cloud, and things are going to be amazing. You're going to get things done. You're just going to, soar. It's just no other way to put it. But what happens frequently is not soaring. It's something the opposite of soaring. A lot of times, what we're talking about is crashing, literally hitting the ground real hard. And it does happen. So the key is preparation. If we want to soar, we don't want to end up in this situation, we need to make sure that we've prepared properly. Now, the thing is that there are some serious challenges to Azure. There's no denying it. You can't get away from it. It absolutely is an issue. But that's not to say you can't overcome it. So one of the first challenges you're going to face is that it is on the internet, and that comes with a whole slew of stuff. I have wonderful service to my house for the internet. It is great. It is online most of the time, and by most of the time I mean, you know, several nines. However, it does go down. It is occasionally slow, and so please assume that that issue is going to come up. You're going to have issues with connectivity. I was actually on SQL Cruise teaching a class last year, or when I was teaching a class on Azure, and I made connections up, and I hit issues on connectivity. And it wasn't just a bandwidth issue, it was literally a connectivity issue. So that's going to occur. You're also going to hit performance issues. Remember, this is other people's servers, and you have to worry about the internet, and you have to worry about your connectivity. So performance could be an issue. Things could slow down. You are going to have to worry about latency. However far away you are from the internet, however far away you are from these Azure servers, however far away you are from Azure SQL database, you're going to have to get concerned about this. You are also seriously going to have to consider data movement. How are you moving your data? You cannot simply assume the same type of data movement that you do today, the local data movement where it doesn't matter how much of the bandwidth you consume. That's not going to work once you move into the cloud. You have to reconsider when you move your data, how you move your data, and most importantly, where you move your data. Now, another challenge that you're going to face is cost. You're going to hear a lot that this is cheaper, and it can be. You're not paying for your own servers. You're not paying for your own electricity. You're not paying for your own air conditioning. You're not paying for your own backup generators. So all of those costs can be to your benefit, but it's not free. And depending on how you set up things, depending on how you've configured things, depending on the amount of bandwidth you use, the amount of data movement you have, the amount of data you're storing, those costs add up, and you could hit challenges on cost. Do not assume that it will always be cheaper. You're also going to look at issues with disaster recovery. Now, we're going to talk a little bit about some of the disaster recovery stuff that's built into Azure, but again, just like you're responsible for your own DR scenarios locally, you should still take responsibility for DR issues out in the cloud. You cannot assume that just because Microsoft has built some pretty fantastic DR stuff into the process that you can have that. Finally, you might hit legal issues. Depending on what country you're from, depending on which government entities you are involved with, depending on your industry, there are different data requirements. My understanding, again, I don't work for Microsoft, so I can't answer it. My understanding is that they've answered most of those. If you're in healthcare, that they actually meet the requirements for the healthcare stuff. If you're working for the government, they actually have government level stuff in different at different data centers. All that stuff is there. However, you have to assume that to be a challenge to you, that's going to be a limit to you. It is something you're going to have to stay on top of. Now, I've said all these challenges, and I don't want to come off as highly negative. I'm actually quite positive about Azure, about Azure SQL Database, and Azure SQL Data Warehouse, DocumentDB, all of these things. They solve most of these problems. They get you over the hump in most of these areas, yet these challenges will remain to you. You cannot ignore them. You must plan for them. Further, there are limits. Azure SQL Database has limits. You need to make sure that you are aware of the limits going in. If you are going to exceed these limits, then Azure SQL Database might not be a good solution for you. Now, this is not the old days. This is not, 6 years ago when Azure started, and it was, limited to, a gig or 5 gigs of data. We are way, way beyond that. It is not the same. So please don't assume that that's how things behave. But one of the limits you are going to hit right off the gate is authentication. If you are used to Windows authentication, and if all you've ever done is Windows authentication, know this, it is not there. You will not be able to use your Windows authentication. Now, again, you have options. You can use a SQL login just fine, or Azure Active Directory is available, and you can connect Azure Active Directory to your own network and do hosting across so that you can use your local connections. But all the connections are through TCP/IP, and you must take this limit into account. Now, you're also going to be limited on size. Now, that limit is pretty insane. So let's say that you've got a database that it's 2 gigs or less. Great, you're in. Now, before you all run screaming, going, "Oh my God, I've got bigger than 2 gigs," that's fine. Azure supports up to 1,000 gigabytes in a standalone database. So you've got quite a lot of room there. Now, if you set up an elastic system where you've got the expandable capacity, then you've got 10 gigs to 750 gigs for your database. So if you're looking at a multi-terabyte database, you might be outside the limit here. But for most of us working with 50 gigs, 100 gigs, 300 gig databases, which is what I see, that's the average. That is, most of us fall well within that range. Then you're great. You're going to see that stuff whether you're on the standalone database or within the elastic pool. If you've got in memory, you're going to be a limit 1 to 14 gigs. Now, it's still in memory is available. It's there working. And by the way, let me tell you, all these limits that I'm giving you, these actual numbers that I'm hitting, these are the current ones, but this constantly shifts. I wouldn't be surprised, and I checked these a little earlier this week, but I wouldn't be surprised if by the time you go and look, this stuff may have already changed. You're also limited on the max concurrent workers, somewhere between 30 and 2,400, again, depending on the tier that you're willing to pay for. You're also limited on max concurrent logins, 30 to 2,400, again, limited by the tier that you're willing to pay for. Now, when I talk about tiers, we also have to talk about processing capacity. So the processing capacity in Azure, specifically talking about Azure SQL Database, and all this I've talked so far is Azure SQL Database. You are talking about something called a DTU, a Database Transaction Unit. A Database Transaction Unit is basically a measure of throughput. It's not specifically a transaction the way we think of transactions. It's more along the lines of, this is how much resources a transaction would use, and therefore we measure it based on that. But the limits there are between 5 and 1,750 for a standalone Azure SQL database, or if you're looking at Azure, the Elastic Pool, which is, by the way, I should mention the Elastic Pool. The Elastic Pool is a management tool. It's not so much a different structure. It's not. It's just it's a different way of managing your databases so you can have a flat fee. It has 100 to 1,500 DTUs per database. So again, depending on the tier that you're willing to pay for, you've got the limits there. And finally, there are limits on the disaster recovery. Now, Azure has a couple of things going for it in terms of DR. You've got backups and point-in-time recovery done for you in Azure SQL Database. There's nothing that you have to do or add if you don't want to. If you're willing to just completely rely on their DR, and if you remember in the challenges section, I suggested that you should not do that. But if you do just rely on their DR, then if you're looking at a basic tier, you have up to 7 days point-in-time recovery. I've tested this multiple times. It works really well. If you're on the standard tier, you get up to 14 days, 2 weeks of point-in-time recovery. And if you're on the premium tier, you'll get 35 days of point-in-time recovery. If you need more than that, it's on you. You will, at this point in time, you will need to make sure that you set up backups so that you have that. Now, another DR scenario built into Azure that you can take advantage of is geo-replication. And you can have up to 4 readable secondaries in the geo-replication. And the beauty of the geo-replication is that you've got multiple off-site secondary power plants ready to go for your system. Complete geo-replication, so you can have your databases replicated between multiple continents, multiple countries. You know, again, depending on the legal requirements of your data. If you can't do that, then don't. But if you can, take advantage of it. That's all built in for your disaster recovery. And now, so that's all Azure SQL Database. I also want to talk about Azure SQL Data Warehouse. I think Azure SQL Data Warehouse is going to change a lot of things. I think it is a game changer in terms of how we're going to do our data processing going forward. The limitations there are different. First off, we have a 60 terabyte limit on the Azure SQL Data Warehouse. Your concurrency slots are between 4 and 60, and you have a limit on concurrent sessions of 1,024. Now the limits after that become, you know, 2 billion tables, 1,024 columns per table, you know, the standard kinds of limits you expect to see inside of SQL Server. Now, in theory, if you're talking about migrations, you're probably all already using SQL Server. You're just using SQL Server locally. The limits that you have now and the number of indexes, the data types, all that stuff, that still applies to Azure, Azure SQL Database, Azure SQL Data Warehouse. So it's not, there's nothing magic there. We're not eliminating some of those things. The one limit that you will see, the one real limit that I found so far in the work I've done with Azure SQL Data Warehouse, though, is in the change from T-SQL, Transact SQL, to D-SQL, the Data Warehouse SQL that they're using within the Azure Data Warehouse. That bit of change is the biggest limit, I think, and it's not really a limit. I kind of hate to say it that way, but it is. You're going to have to spend some time learning and make some changes to the way you do things. You might even have to change some of your code when you go to the Azure SQL Data Warehouse. So those are your limits. Let's start talking about the fun, because God knows, just talking about challenges, just talking about the limits, that's, you know, that's nowhere, you know, it's just not enjoyable. So let's talk about the different kinds of project types, because you want to think about, if you're going to move to Azure, you want to think about where is it, you know, where's it good to make these buildings? You know, where should you place this site? Where should you do the building? It's not, all projects are not created equal. All projects are not going to move to Azure that well. You need to think that through, because you don't necessarily want to just charge off and throw everything at the cloud. I'm sure Microsoft would appreciate it if you did that, but you know, you might not. So let's talk about it. So if we're talking new projects, got that nice, beautiful green field, and you're off and running. You know, I mean, it's clear, it's golden, and you can go. It's the easiest thing to talk about. Saying, yeah, hey, I've got this new project, we're going to move to the cloud. Of course, no one questions it. It's new, it's green, you're going. Fine. Just remember, the limits that we've been talking about still apply. You can't get away from the fact that, you know, greenfield or not, you cannot go beyond those limits. Also, if we're looking at a new project and we're going cloud only, great. That's an easy pick. You know, if you're already building everything up in Azure, awesome. Where should we put the storage? Azure SQL Database. We're moving everything into, you know, the new BI world of Power BI, and everything's going to be up on the cloud. Where should we have our storage? Hey, easy decision, Azure SQL Data Warehouse. If you're looking at the cloud primarily for this new project, not necessarily everything's in the cloud, but most of it is. The data collection is, maybe some of the data consumption, maybe not all the processing, but most of it. Great. It's easy. We move to the cloud. Again, the green field is the easy one. It's the easiest one to talk about because you haven't done anything yet. You're not looking at like, old issues. So easy, not hard to make this decision. And the beautiful thing is that if you're looking at this green field, if you're looking at moving into new projects, you're looking at moving past, what the way you've done things in the past, but it's all new. There's no admin or little admin. And again, DBAs, don't freak. Your job is not going away. You've got as much work. You've got more work here. It's just the type of work shifts. However, if you're a small shop, your developer primarily, you're few in terms of administrators, then again, this green field looks very attractive. It's a good choice. Again, green field, no infrastructure or little infrastructure. A huge win, not necessarily for everyone, not necessarily applicable to all of us, but it's another win for why you would move. So again, I just want to say the new project, that's easy. The new infrastructure, that's easy. The new admin, that's easy. Let's talk about the hard stuff. Let's start talking about the things where this gets difficult. And so what we're talking about is the existing projects where we've got brown fields. It's not green fields, it's a brown field. And I don't know about you, but my brown fields don't usually look this pretty. My brown fields usually look like this. We've got a lot of issues. There's all kinds of projects that are going to lend themselves to a move to Azure, to a migration to Azure SQL Database, to a migration to Azure SQL Data Warehouse. First up, instrumentation. If you're talking about collecting usage, for example, Redgate software collects certain types of usage on some of our tooling, and we collect it through Azure SQL Database. We've got Azure SQL Database, and it's a great way to do it. Why? We've got a large distributed user base, and so we need to collect this information as you guys are using it across the world in multiple places. How better to do that than on the cloud? We have an online app data collection, and it's nice, it's simple, it's straightforward. You can also, if you're looking at the Internet of Things, if you're collecting usage on a refrigerator, for crying out loud, or people's heaters and the thermostats and all this other stuff that more and more things are being instrumented, more and more things are connected to the Internet, more and more things are spitting out massive amounts of data. Excellent. Azure becomes a great place to move this to. You can also, don't forget, take advantage of things like Hadoop, take advantage of things like DocumentDB. There's other Azure offerings out there, especially associated around the Internet of Things, that make it easy. Azure SQL Data Warehouse also comes into play. Now, if you've got multiple sources for your data, again, like we were for our instrumentation needs, we had lots of different sources. Again, Azure becomes extremely attractive because the cloud is largely ubiquitous. It is everywhere. Everything's connected to it. So instrumentation becomes a great choice for a migration to the cloud. Don't forget, because Azure has built in the ability to set up readable secondaries, you can collect on one and read from another. You do not have to have everything going through a single source. You can hit multiple secondaries. Let's talk about another type of application that's going to be good for the move to the cloud. It's the web app. Now again, this is easy. If you're already building web applications, if you've already got web stuff, great. Let's move it to the cloud. Mainly I'm talking Azure. The connection between Azure and Amazon Web Services is difficult. I've seen some experiments done by a couple of friends. They had to hop through some serious hoops. They were able to make things connect up, but neither side was terribly happy with that. So we are talking about having an Azure web app, not necessarily others. But if your local app is hitting issues, if you're worried about scalability, you're worried about on-demand, you're not able to get your database and your web app to communicate well. Azure becomes a great mechanism for making that happen. So it's a good place to migrate to. If you're looking at integration issues locally, once again, Azure integrates extremely well. The communication between an Azure web app and Azure SQL Database or Azure SQL Data Warehouse is extremely clear, very clean, very easy. It's also easy on security. Once you've got things set up there so that you've got, the Azure Active Directory, you can connect up these databases and your web apps extremely easily. Don't get me wrong. When I say easy, I don't mean that there's no work. I just mean that the work is simple. It's not complex. It's fairly straightforward. And so that's web apps. Another data type that's very attractive, or data type, another application type that's extremely attractive for making the move, for changing from local to cloud, is when you've got online data consumption. If you are looking at using web-oriented web services, stuff already out there such as Power BI, Office 365, you should be at least considering moving your data storage to the same place the consumption is occurring from, because you don't want to be dependent upon that internet connection for the data movement. It's not that the internet connection's bad or that there's a problem, although again, it's one of the challenges we talked about earlier, but you do need to make sure that you've got the data connection set up. Well, why not have the data connection between this online application that you're using to consume your data and the online data storage? It makes more sense. If you're already there, keep going. If you're processing in the cloud, why not do data storage in the cloud? Logically, that one just follows. I've never hit any issues. And hey, let's not forget those readable secondaries. I get so excited about the fact that we can easily, quickly set up readable secondaries. If anyone's tried to set up an availability group, it's not hard. It's a lot easier than it used to be setting up failover clusters, but the availability group gives us those readable secondaries, but it's, you have to get the enterprise level stuff, you've got to set up all kinds of different services, you've got to maintain all kinds of networking and all that stuff. But if you're looking at Azure, you set up those readable secondaries, and if you're already doing online data consumption, then you've got all that connectivity set up and ready to go. So that, again, that's another data type that becomes extremely, project type that becomes extremely attractive. So what about when we're doing distributed processing, we're doing on-demand stuff. We've got really high-end, lots and lots and lots of processing occurring. Things are going to be happening, in a very, very volatile way. You're going to have, 1 million connections today and 2 tomorrow, and then 10 million the day after that. Azure becomes very attractive. Trying to set up your own infrastructure where you're setting up sharding, where you're setting up the ability to split your database across multiple servers and then have those servers spin up or shut down on demand is a lot of work. It's not easy. Now, it's still a lot of work in Azure, but Azure is built around this infrastructure. It's designed to do exactly that. It's made so that you can spin up a database. If you've at any point connected up to Azure and fired off a database, you're doing already the type of work that you would do for sharding. So the Azure SQL database is built around the concept of sharding already. Take advantage of that, fire up your own sharding. Then you've got the ability to do near real-time expansion or contraction. PowerShell is your buddy, PowerShell is your friend, and you can automate all of your database deployments. You can automate all of your database builds, and you can automate adding or subtracting databases on the fly as you need them in support of this distributed processing that you have to do. The beautiful thing is then you're only paying for what you're going to use. You're only going to pay for it while you're using it. So if you need 1 million connections, you need database structure so you can collect information from 10 million connections today. You're going to set up the sharding. You pay for that today, and then tomorrow you're saying, well, we don't need that anymore. We're going to consume this stuff. We're going to process it out to a data warehouse or whatever. Great. Don't pay for it tomorrow. Get all the processing done and shut down the number of databases and servers you have online. Also, if you're looking at this, the ability to have an elastic pool becomes extremely attractive because elastic pool provides you with a metered experience, meaning you can decide I'm going to pay this much per month, and you're not going to be looking at a changing cost structure. You're going to look at a single cost structure. I'll pay this much a month, and I get X amount of processing, and I can expand and contract within that level of processing. So once again, Azure is a really, really attractive way to get this done. The on-demand distributed processing project type is very good for Azure. Another one, you've got parallel processing. You're looking at the large scale simultaneous processing that's occurring at the same time. If you're doing this locally, again, it is a heck of a lot of work or a heck of a lot of money. You can pay for APS and get it all set up locally. That's great if you're able to. So you can get this going, but in Azure we have parallel processing through the Azure SQL Data Warehouse. That is a game changer. I think it's going to rearrange the way a lot of stuff is done. The beautiful thing is that you can take advantage of this. So let's say you need to process a whole bunch of data. You need to collect, you've got data collected, great. You collect it online, offline, who cares? But you've got to get this stuff processed. You've got to move it into a new structure. Take advantage of the fact that Azure SQL Data Warehouse is built around parallel processing. You set this up, it fires up multiple machines under the covers, you don't see them, and puts them to work for you doing lots and lots of processing all at the same time. It's actually a lot of fun to watch. As you're doing these parallel processes, it's not something that you see, it's just something that's occurring under the covers. But you can do all the processing through the Azure Data Warehouse, and then once you're done, once you've got all that done, you store it someplace else. Either move it to an Azure SQL database, or move it down locally, or move it into another data structure, and you're off and running. You can shut down that parallel processing after you're finished with it. Again, this is that pay on demand type processing, and you're finished. You can keep going. And you can also bring in stuff like Polybase. If you move around data in files, flat file, lots of Internet of Things, data types, data collection goes through flat files. You're going to see a lot of that kind of stuff. Polybase is the mechanism we have for querying across systems. We can query from Azure SQL Data Warehouse to Hadoop. So if you're doing your data collection through Hadoop, great. Do your processing through Azure SQL Data Warehouse. Write the query so that it goes straight to Hadoop. Write the query so it goes straight to that flat file that you've collected through some other process. You don't have to rely on having everything in one data structure. You can do the processing through the data structures you have in place. Use the data in place. Don't have to move it around. Process it as needed. Restructure it as needed, especially using the parallel processing power of the Azure SQL Data Warehouse. But don't have to depend on the fact that it's, a data move, and you've got to move the data, and the time involved in moving data, the effort involved in moving data. That goes away when you start using Polybase, and that's another thing that makes this parallel processing that much more attractive. And the fact that we have it on demand, we can spin it up and then shut it back down after we're done. Once again, that makes Azure extremely attractive because you're only going to pay for this infrastructure while you need it. Rather than go out and buy this thing, you can get it done locally. That's another project type. Yet another project type is when we start looking at the multi-tenant software as a service applications. And you've got, this again is that type of elastic load. A lot of things are going on. You've got to spin things up. You've got to shut things down. And the software as a service applications, there's a lot of infrastructure work you're going to have to do to get this set up. But if you've got this combined service offering where you're doing multiple different types of services at the same time, Azure and Azure Storage, Azure SQL Database, Azure SQL Data Warehouse become extremely attractive. Because if you've got the same structures, but you've got varying loads, if you've got varying access paths, you've got varying security levels, but again, same structures, you need the ability to quickly and easily spin these things up or shut them down, to manage them through a single pool, to manage them through a single location without having to pay for multiple mechanisms of storage, multiple mechanisms of power, multiple mechanisms of air conditioning, multiple mechanisms of buildings. Rather than do all that, you move to Azure, set it up there, take advantage of the fact that you can distribute this stuff through the multi-tenant process, and Azure itself is multi-tenant. So again, that type of infrastructure is designed in place for you. So you're not going to have to do a lot of the infrastructure design, the infrastructure work that you would normally have to do, which is why, again, Azure becomes extremely attractive for this type of project. If you're already doing this kind of work, you know how much labor it is. It's not easy, but Azure is going to make it easier. Let's talk about another project type. This is the Azure SQL Data Warehouse. Now, APS, great thing. The parallel processing power is pretty amazing. It really is. I mean, the technology. The first time I saw it, I wanted it, and then I found out what the cost was, and so I didn't want it as much. But now we all have APS. We can all fire up Azure. We can all fire up Azure SQL Data Warehouse, and we have APS. It's available. It's right there. We're no longer limited to buying massive amounts of infrastructure and setting them up inside of our own systems. We've got an online warehouse system ready to go. You can spin these things up and tear them down. Now, if you are looking at more than a terabyte of data, you want to look specifically at Azure SQL Data Warehouse. Azure SQL Database is not going to be that attractive for that type of workload. The amount of data there, again, if you shard it, great, you can do that, but it's going to be more difficult to manage. But that Azure SQL Data Warehouse, if you're looking at that multi-terabyte system, that's where things get attractive. That's where you do want to make that move. Now, if you are looking at under a terabyte and you don't need massive amounts of parallel processing, great. You don't need to go to Azure SQL Data Warehouse. You can take advantage of Azure SQL Database and the column store. You can pivot your data so that it's stored column-wise and use column store indexes, clustered column store indexes, non-clustered column store indexes, and plug that right in so that you're taking advantage of the fact that you've got an in-place mechanism for doing your data warehouse. You don't have to build this data warehouse. You can just take advantage of the structures that allow you to use data warehouse processing. Another place where the data warehouse becomes extremely attractive is in the machine learning. If you're moving into some of this new process, the new machine learning processes, most of those are going to be online. And if you're looking at online processing, where do we want to go for data storage? Hey, let's go to the Azure SQL Data Warehouse. Let's go to Azure SQL Database. Once again, I'll bring up Polybase. The ability to query across different storage types so that you can do, in-place storage, in-place querying of your in-place storage is a huge win. It's not an insignificant thing. It makes a change in how we design stuff. We've long had this whole thing of data movement, BI movement, that we've had to go through. But with Polybase, we start talking about just leaving the storage in place and dealing with the processing of it, consume it in place rather than trying to move it around. Also, this is one of my favorite features with the Azure SQL Data Warehouse because, frankly, it does get costly. It does, parallel processing is not free. There is a cost associated, but we've got the ability to pause. So we're not looking at paying for this stuff forever. You're not looking at, buying an APS system anymore. You're renting it, and you're only renting it for while you need it. You can pause it, and the beauty of the pause is you can leave your infrastructure in place. You can keep the data going fine if you want to. You'll pay for that. You'll pay for that data storage, but you don't have to continue the processing. You pause it and you stop paying for it. You'll only pay for the data storage at that point. This makes this very attractive. Again, this is one of the reasons I think it's a game changer. It gives us parallel processing when we need it, and only when we need it. We're not dependent on buying big hardware. We can just use big hardware like we're one of the big boys. Maybe you're not, a multi-billion-dollar corporation that spending, a couple of $1 million for a data warehouse is no big deal. Fine, go here, take a look at this stuff, because it gives you the same capacities, the same capabilities that the people who are going to spend millions of dollars, but you get it for a lot less, frankly. All right. So again, I'm a huge advocate for Azure. I'm a giant fan. I sound like I work for Microsoft frequently because I am that excited about it. However, I want to bring up again the challenges. This is not free. Nothing is free. TANSTAFL, there ain't no such thing as a free lunch, always applies. You cannot get away from it. These challenges are there. They are going to happen. You're dealing with the internet. You can't forget that. You've got connectivity, and connectivity issues arise. They absolutely do. Performance is great in Azure, but not always. And it does depend on how you've set up your service tier and everything else. Latency is going to be an issue. You cannot escape it. You are moving things across the cloud. What is it? It's about a meter that a bit can travel in 1 microsecond. So that's a limit. It's a physical limit. It's a hard limit that you're going to have to deal with for your data. Data movement becomes much more difficult in the cloud, dealing with this stuff. Data movement becomes very hard. The costs can grow. Again, I love saying it, TANSTAFL always applies. You are going to have to deal with disaster recovery. We've got stuff built in, but you can't escape it. And then you've got those legal issues. Now, these challenges exist. You are going to have to climb that cliff. However, the technology that's in place in Azure deals with most of these challenges, helps you with most of these challenges. These challenges are not, they're challenges. They are not hard stops. This is not, end of game events. These are just things you're going to have to deal with. You're going to have to get on top of and make sure that you're aware of as you start to move into the cloud. I can't emphasize them enough. As excited as I get about the cloud, as much as I want you all to start moving into Azure, just because I love it and I want to be able to teach it more, frankly, these challenges are there and you need to take them into account. You cannot ignore them. You want to make sure that you're very much aware of them and on top of them. Okay, cool. How are we doing on time? Excellent. So once again, my name is Grant Fritchey. This is my contact information. You can get in touch with me. I would love to answer any of the questions you have on this after today, but today I've got a little bit of time set aside. I tried to make sure that we had some time to discuss things, and I would love to answer any other questions you have. So how are we doing, Edvaldo? Do we have anything?
I Hi, Gwen. Great presentation. Actually, we have no questions here in the
Whoa.
pane, but that means you
Oops.
made a great presentation. It was awesome. Sorry. Yes, it was awesome.
Okay, well
Uh,
let's pause here for a second. See if
sure.
anyone has questions, you can type them into the question pane. I don't see it on my screen, but you should be able to see it on yours.
Yeah,
And there's
that's
got to
it.
be a question or two because I know I didn't cover everything in detail. Okay.
That's right. No.
Wow, I am shocked.
One question here,
Ah,
or just a moment.
sure.
Just a moment, please. We do a lot of external ETL, Azure. I'm sorry, the pane is not that good. Just a moment.
Okay. External ETL Azure.
Yes, let's go again. We do a lot of external ETL, Azure. Um, not a good choice. That's what typed.
So
Make
they do a
sense to
lot of.
you?
Oh, so what they're doing is they've got a lot of they've got multiple sources of. I'm going to make assumptions based on what they said. So if I'm wrong, they can correct me. They have multiple sources of data, and so they're doing multiple ETL processing. So they're bringing in, say, spreadsheets from 50 different locations, and they're doing the data import locally and all that stuff. Great. Yeah, actually, Azure is a great choice for that because two reasons. One, if you're moving a lot of data around, so you're emailing spreadsheets or moving spreadsheets between different kinds of data storage, stop. Start putting them all into a single location. Put them up into Azure File Storage or someplace else up there, and have a single location for that stuff. Better still, have Azure for the data collection, and then you don't have to do any kind of ETL. However, let's say we are still talking about it's point of sales is a great example. So you have disconnected point of sales, lots of cash registers collecting data, and then once a day or once a week or something that they're connected up to the internet, and all that data is moved up, and then you've got to do ETL across. Yes, Azure is a great way to get around that. Two reasons. Again, I already mentioned it. You've got a single point for your data collection, but then you can do all the processing online, and you're reducing the amount of data movement that you're going to have to do. You do the processing either, you can do parallel processing through Azure SQL Data Warehouse, or you just process this, or heck, read it using Polybase, or process it through Azure SQL Database and then store it there. But it's a great place for doing that type of multi, source ETL.
Okay, we have some more questions here.
Okay.
Is their data advisor tool useful? I just have concern trusting this tool to move workloads into the cloud.
The Data Advisor tool, is it useful? Okay. I'll give you the honest answer since I don't work for Microsoft. No, I don't think it's all that useful. I've not found it to be terribly accurate. However, it does give you a starting point. It gives you a guess. It's not going to give you an accurate estimate. It's not going to give you a precise measure of what your data load is going to cost or how your data load is going to migrate. You're going to have to do a little bit of testing and development on the side to validate how your move is going to go on into Azure. I would not. I would use the tool, absolutely, but I would not trust it. I would make sure that you do your own testing on top of what that tool tells you.
How can Azure address P2 or PII and security for sensitive information? Can you encrypt?
Okay. Well, I am not a security expert. I'm glad these questions are going to be available because I will track down who has that answer. You, Microsoft has encryption built into a lot of these things. It has encryption built into the storage. I'm not an expert in this area, so I'm going to say yes, that stuff is there, but I'm going to also say no, I don't have the details, and I'm going to conclude with I don't know. That's one of my favorite answers. I know a lot of people aren't satisfied with that one, but I'm going to go with I don't know because that's the best. That's the best one. I'm pretty sure all that stuff is built in there, but I don't have a good answer for that. I'll tell you who I would go to, and who I am going to go to with this question, and so you could follow up with them on your own too. Is Denny Cherry and Associates. They're doing more Azure work than anybody I know outside of Microsoft, and also just so happens Denny wrote the book on database security, so great resource. That's the one place I would suggest to track down. And you know, again, they're doing a lot of work in that area, so they've got that knowledge.
Okay, we have one more question.
Cool.
Great presentation, Grant. Regarding the capping database in Azure, can you please explain how does it work in terms of costs?
In terms of capping?
No, costs.
Oh,
how much
costs.
is it cost? Yeah.
Okay. Well, the cost is simple. Well, it's not that simple. Let's talk just Azure SQL Database for a minute, because that's the easiest one to explain. You're going to pay for service tier. Your service tier comes with two things. Your processing power, meaning the amount of memory you have, the number of CPUs, the speed of your disk, all of that stuff is built into your service tier. And the size of your database is built into the service tier. So, depending on the service tier, you have bigger databases and more processing power. If you need more processing power but less storage, tough. You're going to pay for both every time. And that's just how it works. The more processing power you need, the more storage you get. The more storage you need, the more processing power you get. And that one's straightforward. You want more, you pay more. Azure SQL Data Warehouse. Oh wait, well hang on. Yeah, hang on. Let's not go there yet. Now, Azure SQL Database still. Most companies get kind of freaked when you say, well, yeah, we're going to pay for what we use and blah, 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 and they realize they're like, wait a minute, we have a cost structure. We need to know what we're paying month on month, and we can't guess. So there's this thing called pooling, and basically you pay for a resource pool, and you say, okay, well, we're going to use X amount of DTUs in a month, maybe. We're going to pay for a pool of DTUs. We're going to pay for a pool of data storage, and then we will use some of it. You probably won't use all of it. You're going to pay, and it's like buying your servers today. Do you use 100% of the CPU you buy? No, you don't. Most of us are using 30, 40, 60% of that CPU. We're not using 100% of the CPU we paid for. Same thing here. The data pool, you're going to use 70% of it, 80% of it. You're not going to be using 100 because once you hit that cap, you've hit the cap and it won't go any further. But so you can pay for this data pool. The idea there is not so much, it's not so much a DBA tool like, oh boy, I can't wait to have fixed cost. What do I care? Just pay for it. It's a management tool to allow the CEO and the financial officers to know what their costs are going to be. So that's a second way of paying for stuff. Then we go to Azure SQL Data Warehouse. There, you are paying two different ways. You pay for storage, so how much data you store, and you pay for processing. And they're separated. So you can just store all your data in Azure SQL Data Warehouse and then pay for the lowest tier of processing if you're not doing a lot of processing. And then as you need to do more processing, you pay for more processing, and and then dial that up and down as needed while paying for storage separately. So however much data you store is what you store. Finally, in terms of data, there is an added cost that people forget, and that's the cost of moving stuff out of Azure. If you want to move things down to your local servers, you pay for that privilege. You can move as much data up as you want, but you pay to move data down. So that's another cost. And those are basically the costs, and that's how you figure it out. Is you kind of got to go through all that and figure out how much processing power do we need, how much data are we storing, and are we moving data out of the cloud? So one reason why I strongly suggest, if you've got web apps, if you've got online processing like through Power BI, stuff like that, move it all up to Azure. Do everything up in the cloud. Don't move your data out of the cloud, and it reduces your costs. Okay.
Great. Is there one more question you have for minutes? If I have an existing SQL Server 2008 R2 database that I want to migrate to Azure SQL Database, do I have control over the database compatibility version? I'm not sure.
No.
I want the risk of big bang upgrade and at the same time the migration to the cloud.
Yeah, it's going to be a big bang. You don't have direct control over that kind of setting of compatibility levels. It's one of the things you surrender when you move into something like Azure SQL Data Warehouse or Azure SQL Database. You will surrender that type of functionality, and it's hard. DBAs are control freaks, and so I'm sitting here telling you, surrender some of your control. And every DBA out there, has a moment of horror that I'm saying that. But yeah, that's what I'm saying. You are going to surrender some of your control. It will be a big bang move, but you can't get away from it.
Great. That's all for now.
Cool.
Great. Let's go to the next slide, please.
All right. So that's a wrap. Thanks for attending. 24 hours have passed. And I'm assuming, Edvaldo, you're supposed to wrap this up, not me.
So thank you all for attending 24 Hours of Fast Evolution of the Data Platform. We look forward to seeing you next time. Thank you. Thank you, Grant.
No, thank you. Appreciate it. And thanks for everybody for attending.